So tell me about a bit about yourself in terms of how did you get into containers and where have you deployed them and how?
Well, I started using containers 2 years ago. I was very new to the DevOps world, so coming to this position where I have to work on a continuous integration stack, non-existent continuous integration stack to actually make use of containers, which is funny because when I got to the company, containers were used in everything except continuous integration, continuous delivery. They were used in automation. They had containers for various stuff, for DNS servers, for repository managers like Nexus and all that. But they were not using them for
CI/CD. Yeah, that's so funny.
No, it's funny because like even Solomon Hayek's, he's the CTO of Docker. When he started, evangelizing Docker in companies, like when he just started, he was actually the selling future of Docker was it's a tool to help you for continuous integration.
Yes, so I would ask, who's running Docker in production? Hands would go up. Okay, if you're running CI/CD, put them down, and all the hands would go down. So I mean, that was the.
That's true. Well, that's the funny part. I think they just realized to a certain, they got to a point where we're not using this for the right thing. That's how it started. I've never used Docker before. I didn't even know what Docker was. So
Docker was pretty much brand. And 2 years ago, it was pretty new still.
Yeah, well,
right. We open sourced in March of 2013, and I don't think it was until the end of 2013 that people.
When did they have the first DockerCon?
So the first DockerCon was until 2014. So this is all very recent. This has all happened in the last 25 minutes. It's not just you. So 2 years ago.
Okay, makes me feel so much better.
You're an old schooler. Yeah, you don't have to feel. Yeah.
Okay, so I got there and we actually built a continuous integration, continuous delivery stack from scratch. There have been good and bad experiences.
So what were you using as part? Is it Jenkins for the?
Yes, okay. It was all based on Jenkins. I think, we were using CloudBees, enterprise version, and the open source book. Okay. Yeah.
And so, what were some of the things that worked in that? What were some of the things that you struggled with?
Well, I just got there and I found it in front of me this monolithic multi-tier application.
There you go, right.
It feels. It's funny because I found an article on Join talking about containerizing monolithic applications.
Yeah.
But I don't think that would have helped me. But it's just so. I think I had a really bad experience with trying to put monolithic applications in containers for the simple reason that you get to a certain point where, I'm going to speak from my experience. I found that gradually, if you're in front of a monolithic application, a front end and a back end, and you have a couple services running too, I found myself in front of exponentially growing file system fingerprint of the image. Like I end up with images that are 5 gig and 6 gig.
Oh no!
And
yeah, it's bad. Yeah, that's bad.
That's when I start raising the red flag for the company. I'm like, this is probably defeats the purpose of using.
Right. Interesting.
So, but I think.
And was that just because you're pulling into this monolith? You had so many dependencies and dependencies and dependencies.
Right.
Okay, right.
So, so the application itself, the way it was constructed, it has like tremendous amount of dependencies. It's just ridiculous.
Right.
Like all the libraries for credit card tokenization, for all the libraries that the app needs. It was a Spring-based. Java Spring-based application, not even Spring Boot. So, it has
old school
just,
Spring.
Old school Spring. So we got to a point where it was just, I think the mistake was actually we were so much, under pressure to create a continuous integration, continuous delivery stack, making use of containers that actually we lost the objective. Why do we use containers? Because we want to have something that's going to be easy to move from one environment to another. And I don't think that a 5-6 gig image is actually easy to move from the developer workstation to the test to the QA to the production. So
that's an interesting point. I mean, we think of it just as kind of being poor hygiene, but you do get to the point where the images get so large that it's actually, I mean, just downloading this thing on your laptop is going to take, I mean,
right.
even over good Wi-Fi is going to take a while. I mean,
right.
This is big.
It was really big, and it really defeated the purpose. But, okay, I'll get it later.
Yeah, that's right.
So we got to that point where actually we had to stop and think about it a little bit, because when we just first started, we thought that, well, Docker is going to be the solution to everything. It's going to make everything easy, but it didn't. The good news is the companies start thinking in different ways, and they actually come up to, well, why do we not break the application into microservices? I mean, let's look at the front end and make use of a single page application if you're familiar with the technology, and that gives you small portions of code that are not very heavy, and you can easily put inside a container and have a literally small file system fingerprint that you can move from one environment to another.
So that's funny. So it's kind of Docker and CI/CD inspiring microservices instead of vice versa.
Well, I think that was the one of the motivations that pushed the company to actually start using microservices. Plus, there was probably other motivations. I mean, with all the benefits that you get from microservices, like circuit isolation and all that. So, and when I start using, and I don't know if like the containers came at the same time that microservices were start existing, and it's just a good combination.
It is a good combination. It's one of those questions of like, and I think that you have to conclude that they're each accelerating the other, because they did arrive at, I mean, a bunch of folks, including us at Joyent, a bunch of folks were doing microservices before they were called microservices. But if you look at when we were doing that transition in 2012, 2013, and I think microservices, the term, did arrive at about the same time as containers. So yeah, I mean, these are two trends that are reinforcing one another for sure.
Right. So I mean, we probably learned the hard way, but if any one of you actually is working with microservices, if you start Dockerizing microservices, you'll really feel that you are taking full advantage of what Docker is. I mean, it's really easy to put starting from writing a Docker file from a microservice to actually seeing that microservice in production running.
Right.
And no matter what you use in your tests or production environment to orchestrate your containers, Mesos, Kubernetes, or you want to go with Docker Inc. tools like Compose and Swarm, you're going to see that it's really easy to manage, it's really easy to move, and easy to bring down to.
So yeah. So you saw. I mean, it sounds like part of a big transformation then from that monolith to the microservices. And did people see those advantages pretty quickly in terms of being able to?
Yes. That, I mean, it was pretty pretty obvious. I mean, so the company was actually it was a huge shop for developers. It was probably 400 developers if you include the app, the mobile app, and all that. So you can imagine the velocity of code generated by those people, and how much is the CI/CD vital to actually, help the release management and all that stuff. So there is really a lot of code generated from those people every day, and I think every day it's probably more than 20 build. Well, I
was going to ask you, I mean, moving from a monolith to microservices, did you find that your release velocity accelerated? Were you able to release software faster into production?
Well, what I can tell you is that the amount of code was definitely more than what we had before, because there's various teams working on different applications, and like they're continuously coding. So you have more entities in your application, so you have more code generated. So the reason I'm saying that is you have a lot of code generated, and the CI/CD is really important in the process of release management, and they can't afford to so the notion of time is really important there, because think about the time you need to actually stand up an application that is just 3 images, each one is 6 gig, versus probably 12 containers that are 100 meg each. It's really, really, like, you can see how much time it's going to take you. So that the time was actually less to actually start an application based on microservices than the monolithic one in a container. I'm making the comparison assuming that the 2 applications are containerized. So that definitely helped them with their CI/CD process.
And did you, in terms of with that monolithic app, was it already kind of upgradable? Because what I found is many monolithic apps, they're such a pain in the butt to upgrade that no one wants to touch them.
Nope.
And they end up getting kind of weeks and then months and then 6 months, and then they're so far behind that now they're seeing all these issues that have already been fixed or what have you. And you finally go to upgrade this thing, and upgrading a monolithic app is terrifying.
It is very annoying, actually, because so when you see the flexibility you get with microservices and how you can how they are modular and independent in a certain way, you just need to find a way to actually keep track of your versioning system, like semantic versioning, if you're going to use that, or use manifest to actually keep track.
So let's talk about that. That's a huge problem. So let's talk about that. How do you do that? How do you keep?
Well, it's different from company to company, and I've noticed a lot of companies like to use semantic versioning. The way I did it, or we did it, is we actually had a very simple manifest to keep track of each component version, each microservice version.
Okay.
And that way, with each time you actually want to update a component or microservice, you just need to update that manifest and just for the specific microservice that you just updated.
Yeah, so in terms of the semver, you'll update the semantic version, or are you just describing the interface in more detail, or just the semantic version?
You're describing actually each microservice and the corresponding version of that microservice.
Okay, interesting. Yeah, the problem we found with semantic versioning is that there's so much gray area.
It's not clear.
And we have broken ourselves. I don't know, maybe you didn't have these problems, but one of the problems you'd have is you've got a field that you think isn't being used. And so you become much more strict, for example, about the fields that you're accepting. And so you have a microservice that used to be much more lax, and if you had some garbage field that I was ignoring, I took it, and now the service actually kicks out an error, which feels like an improvement, until you got some client of that was actually due to a bug or what have you. So there's a kind of a bogus field that's along for the ride, and it's so is that a major number version bump? Is that a minor version bump? You just kind of fixed a bug. I don't know. These are the issues that we found.
So I don't know. The manifest solution seems to actually work for that particular case. I honestly don't know how would a semantic versioning work with microservices. Until this point, I have not a chance to actually see a use case of that.
Yeah, interesting. We use JSON schema, which has been pretty valuable to kind of describe what the schemas actually look like. So you describe the interface a little bit better. But it's definitely a challenge, right? Because you end up with it's easy to end up. I think there's one of those tweets that with microservices, every outage becomes a murder mystery because it can be hard to figure out what actually broke where.
It is hard, but with a lot of advantage came a lot of disadvantages too. So you have the flexibility of updating every model, each model you want, without actually have to update the whole thing.
Right.
But
which is,
I think you're
right. I think you're right. I think, and that's a good way of phrasing it. That you've got some decentralization, and you're always going to have there's a peril associated with that as well. With that decentralization. How? And you said you kind of came from the DevOps world. So
I was new to the DevOps world, actually. I used to be a Java developer.
Okay. So yeah, right.
I started doing DevOps 2 years ago.
So can I ask you a question? So I'm a software engineer as well. So here's a debate that is raging inside, and for good reason, because I think there's not necessarily a right or wrong answer to this. Google has kind of infamously all of their software * in one repo. You know, so they got like there's the Google 3 repo that has effectively not all Google software, but a lot of Google software. It has 45,000 commits a day, or whatever. Exactly. Do you guys do one repo per microservice? How do you do that? How do you?
So it's probably not one repo per microservice, but there is. You just make use of the pull request, feature of Git, where you actually have your developers working on a certain portion of the code, and have a team that's going to actually validate that.
How does your CI build that? Does it build the entire repo, or do you key it into components of the repo?
You
build individual microservices.
you can build. So you can't build individual microservices, but that was actually one of the improvements they wanted to make, is make a repo for each microservice.
Right. Okay. Yeah.
But at the point I did that, there was no separation of repos for microservices, which was a little bit annoying because you have to build the whole thing.
Yeah. I mean, I think. I can see both sides of this, right? Because on the one hand, a repo per microservice it gives you nice isolation, and you can build them individually, and that feels like that's got to be the right way to do it. On the other hand, there is when you have one a repo that's got either more microservices underneath it or what have you, it's a little bit easier to make changes that are going to straddle microservices. But then I kind of counter that and be like, well, maybe you should be like, maybe that's allowing you, that's kind of enabling behavior, that's kind of bad behavior. I mean, I think I come down on this ultimately as kind of one repo per microservice. Despite its problems, it's probably the only way to do it.
That's really good.
The testing level gets even more complicated when you need a testing that orchestrates several.
No, totally. No, it's hard. But I think what you were saying about microservices is like it creates some new problem. It solves a bunch of problems and then creates a couple of new problems you got to go deal with. I mean, I don't know.
It does. I mean, I think there was a lot of discussion about breaking down the repos for each microservice. But then again, the application we're talking about is a website, and the way of testing it was actually a behavior-driven test. So if you're familiar with the concept, you write your scenario or your story, and there is tools like Cucumber or gbehave in Java that goes through that and starts the browser, and you do all kind of testing that you want. So if you have a scenario from this page to this page, and you write all the steps that you want to see happening in the browser, and your framework just goes through that and execute all those steps. So the annoyance is the way the tests were written, they were not microservices oriented.
Interesting. Okay.
So if, say, for example, you have a microservices for booking and microservices for cancellation, there is a story that does both. So at that point, there's certain effort that needs to be done in writing stories and tests to be oriented for microservices. So to answer your question, if you build a microservices that does booking on a website and you run a test that does the cancellation, you'll end up having a problem because your component you don't have enough component to actually run the test that you want to run. So that was one of the problems that we run into.
How do you solve that problem? That's not an easy problem to solve.
It's not an easy problem. So you solve that problem by actually bringing everything for testing.
Right. Okay.
You build all your microservices and you bring them and you run all the tests. It's the problem. It's going to take you longer. The advantage, it's going to work. So.
Right. Interesting. Are there other questions? I mean, I've got my own questions that I'm happy to. But if folks have other questions, feel free to thanks for injecting that one. It was a good one. So, what were some of the? As you're kind of making this transition, what were some of the hiccups that you had? I mean, are there any things that didn't work? The things that you tried that were like the wrong approach that you backed off of? Or?
I mean, probably the first major thing to remember is not every application can or should be Dockerized. The next thing was actually hiccups while we were working through our ecosystem. Somebody brought earlier the repos. We were running on private repos. We did not use ACS, and I don't think
it's for image repositories.
Yes.
Yeah. Okay.
That's for image repositories. With all the problems that comes with that, I don't think it was the best architecture. because we were having a repo in AWS, and with the growing number of microservices and builds and tests, you have more demand on your repo. Like there is, you spin servers in AWS for behavior testing, and each one of those VMs is probably need to download its new image. So you need to handle that. At certain time, there's certain decisions that are just, like people like to say, out of your pay grade, and you don't, you don't want to get into that. So there's certain stuff that just need time to change, and you just have to deal with it. So private repos are probably not a good idea if you're running Docker containers. Make use of ECS. It has its problems, like Vivek said, but at least it takes a lot of responsibility out of your hands, like handling requests and all that. Later, probably in Docker version after 1.10, I think you start getting a notification message that any private repo will not be supported after this version. So you have to deal with it. I don't know if anyone run into that actually. I haven't used Docker in 2 months probably, but last time I used it on a private repo, it gave me a warning message that any version after the 1.10 will not probably support private repos.
Huh. Interesting. What's that on? I mean, I wonder if I wonder if they were hitting the old version of the repo.
Right.
So because they're at what version are they on the
V1 and V1 slated for deprecation.
Right. So I wonder if you were hitting a V1 private repo.
We've probably been using an old version of private repo.
Right. Hope so.
But
if Docker's shipping out private repository support, that would definitely be worth knowing. You're definitely gonna.
Well, you'll definitely. So if try to stand up go to GitHub and try to find the code for a private repo, an old one like we were using, and try to use a newer version of Docker to pull an image.
Yeah, my guess is that that's a version mismatch on there.
It could be a version mismatch, but think about the problem that will create for a company. They need to bring down their repo and build a new one and put all the images there. So that's another side of the problem. Other than that, I would say microservices, if the fingerprint in terms of file system is really small, that's the best case of using containers.
Have you checked out Alpine? I mean, the Alpine stuff really is cool.
I've not.
Yeah, Alpine, you'll love Alpine. Alpine will. I don't know why.
I'll try. I mean, I've heard you talking about it.
There you go. Yeah.
What else?
So what did you do for state in this world? Because we were talking earlier about state. I mean, state is a challenge. Where did you have stateful services, or how did you deal with persistence in your microservices, or was this all stateless?
I wasn't part of that word because I was part of the DevOps, mostly working on the infrastructure, and we had developers working on the persistence and of the app itself. But I wasn't part of that.
Okay, so you didn't have to deal with
Nope.
you got to deal with an all stateless world from your perspective, which is great. I mean,
it's really awesome.
That's right.
But what I was going to say. So orchestration is another aspect of containers. How do you want to manage your orchestration aspect?
Right.
So you want to go with. And this is just personal opinion. When I look at Mesos Kubernetes, so it gives you the flexibility to not just depend on Docker with all the headache that comes with the configuration. I like to go with Docker component like Compose and Swarm, and not have to actually worry about service discovery and configuring etcd and console and all that. And if you had a chance to test Docker and Swarm combined, you'll actually see how easy is that. Like the flexibility that
well, especially now with 0.12, Docker Swarm begins to look a lot more like Kubernetes, and they've done a lot of stuff.
And have you heard of Docker Data Center?
Yeah, right. And then of course Docker Data Center. Yeah.
And so I think they have people who are working on that, and they're really getting really good results. I was really impressed with I've been watching DockerCon do one that happened in July.
Yeah, it just happened. Yeah.
So Docker Data Center Docker Swarm, Docker Compose, they really matured from last year.
They have, and I think that, I mean, it's interesting because I think as people are looking at Kubernetes and Mesos and all the stuff that's out there, it seems like the Docker container is the thing that everyone's using, Triton as well. But as we look towards orchestration, there are
Orchestration
a bunch of different approaches.
is a really big problem. So when you start like dealing with clustered applications, applications that they're not just one VM or
So for whatever it's worth, this is why we did Container Pilot, because we were kind of a conscientious objector to some of those things because they were so big. So Container Pilot is what allows you to actually allow the app to orchestrate itself, so you don't end up being kind of all into a framework, which I think is a little bit easier than some of these. I think there's some very big frameworks out there that it'd be interesting to see how this all shakes out.
I don't know. Like there's a lot of people that likes to have the flexibility of and not being dependent on a tool. Like if you use Docker and Swarm, you're tied to Docker. If you use Compose and Swarm, you're tied to Docker. But a lot of people like to use auto orchestration tools with their own service discovery to not be tied to Docker Inc. It's their personal choice. I like to, I think we were used to this notion that everything complicated is good, which is not necessarily, which is not
I thought you were a Java developer. I thought Java developers love everything complicated. Is that right?
It is.
Right.
I agree. Like orchestrations tools that gives you more flexibility, it's good. Like you have a lot of freedom.
I would much prefer something that's simpler and smaller.
I honestly like to have something that I can. If you took a look at that paper that Ryan talked to me about, the React and Compose combination.
Right.
So I was at this Internet of Things conference, and they were talking about React and how is it really good tool because it allows this really fast read and write operations for sensors. You can actually have a lot of sensors putting data into a database, a React database, and how fast and easy is that, and how it's fault tolerant, and if a couple nodes die, you don't lose all your data. I mean, all that, Bashro did a really good job.
All open source. This is inspired by DynamoDB. The Dynamo paper.
It was inspired by Amazon Dynamo.
Yeah.
But so I was at that conference, and when I went home and I started playing with React Admin, and one of the parameters in your command line, and you need to specify your master's node IP, and you start automating that, and it gets a little bit annoying where you have to handle that IP address then. And I was like, why don't we just put that inside a container, put it in a Compose, and let Swarm handle that service discovery? And you'll notice that it takes a lot of work off your hand. Like you have all you have to do to scale Docker Compose scale number of nodes. And you have 20 new nodes. You don't have to even worry about what IP address those containers will have.
I mean, I love Docker Compose. Docker Compose is so simple in terms of being able to scale things up and down. And if you have an app like React, like Couchbase, that knows how to, especially one of these data layer apps that knows how to kind of to reconverge with a new number of nodes, it's really, really nice.
It's impressive. I mean, so you start seeing the value when you actually don't have to worry about putting those values of IP addresses and the ports and all that. It takes all that off your hand, and for me, that's huge.
And you're able. I mean, I'm convinced that actually the Docker's made it so much easier to configure some of this complicated software that now people are deploying some of this complicated software. I mean, like Zookeeper, for example. Zookeeper is a gigantic pain in the ass to configure.
It is. I hate Zookeeper.
Right, which means that you've run it. No one who has run Zookeeper has anything other than a complicated relationship with Zookeeper. Right? It's always complicated with Zookeeper because it's so combative. But Docker actually makes it a lot easier to configure ZK.
It gives you that abstraction where you don't have to worry about details. What I was going to say, so Swarm actually gives you even a better possibility of you can spin multiple servers and have this abstraction. You can scale on those servers and don't even have to worry about installing your tools inside the
Yeah, so
virtual machines.
and that's similar. So the approach we took, for whatever it's worth, is so Triton manages a whole bunch of physical compute nodes, and then we actually implement the Docker remote API at the data center level. So if you do a Docker PS, you are seeing your Docker containers across the entire
Yes.
data center. So you're not. It's a similar kind of a thing. It's kind of a swarm. So
And that's something that Joint has?
yeah. That's the
Really?
That's part of Triton. Yeah. So
that's good.
all open source.
I'm sorry, I haven't tried it yet.
No, it's fine. No, but I think it shows. I mean, part of the reason we did that is because we really saw the power of the approach, and because the knock on Docker Compose was, okay, this is great, but you've got to point it at a single Docker engine. And with us, it made a lot of sense because that Docker engine was actually virtualized, represented an entire data center. With Docker Swarm, they actually allowed you to do that effectively, and especially
Right.
with the recent versions of Docker Swarm.
They took a
pretty
lot
cool.
of they did the great work, especially in the networking part, because before I was struggling with that before Docker Swarm came. I was trying to actually connect containers on different VMs without using Swarm, and
yeah.
it's impossible.
Yeah, it's pretty
There-
brutal. Yeah.
So there was some workaround on internet, and it's just not worth doing.
The whole the link mapping stuff is just disgusting.
Yes,
It's
and
terrible.
you have to stand in what they call an ambassador image, and
An
it's-
ambassador.
Yes.
Okay. Yeah, you found yourself. I didn't. Not
No,
that.
I
That sounds
really
ugly.
deep.
That sounds
and
bad.
Yeah, it's really bad. So I
Also,
started.
ambassador. I mean, that's putting the best possible face on it. Like, this is not an ambassador. This is something
Yes,
much more disgusting. than
you
this.
can look it up. There is something called before the Compose and Swarm, they come up with this workaround to actually connect containers across hosts, and it's really called an ambassador image.
Right.
And it's just not worth it.
Yeah. No. That's.
So yeah, that's a huge advantage you get. I was actually running a Selenium grid and standing up a lot of nodes that are talking to one master, but those nodes are distributed on different VMs, and those nodes are inside Docker containers. So I had to find a way to connect containers inside VMs without using Swarm. I didn't.
Yeah. I mean, I, of course, I would have told you to use Triton, you wouldn't have that problem. But no, I think that's and they've made it a lot easier, certainly. With
Yeah. At this point, I'm definitely pro. I'm sorry, I can't. I mean, I know that Mesos and Kubernetes.
No. I
have
think
large
it's fine. I think it's great to have an opinion on this stuff.
It is.
So, yeah.
I think I'm a little bit biased because I just find it better and easier to use.
And I think one thing is, again, it's interesting. Is,
I prefer to sacrifice freedom and flexibility.
Well, I think that one of the things that's great about all the options is, unlike I think in kind of again previous revolutions, these are all open source options.
Yeah.
So you on the one hand, like, okay, you may be making a choice, but it's not like a proprietary lock-in the way it used to be.
No, it's not.
And I think that as a result, there's no reason to not be more opinionated and say, hey, Swarm's working for me. I think that's great.
It is.
Are there other questions for Mohamed? Yes.
Any idea the delta between the lifespan of the containers after you transition to a VM mode?
I'm sorry. Can you say that again?
So the lifespan of a container versus the lifespan of, or what is the average life expectancy of a VM versus the life expectancy of a container?
So it depends on your use. In this case, we're using containers mostly for continuous integration, and the model, the standard model for continuous integration. Well, let's talk about continuous integration first, because continuous delivery is something completely different. So for continuous integration, you stand up your app for testing purpose. You run your unit test, behavior test, functional testing, and all that. And once you're done,
It's gone.
You're done.
Yeah.
VMs are different. You stand up a VM because you want a server to run something, and it's going to be the time you need to run that service. I just see it that way.
Yeah.
So here's the thing. We stand up VMs in AWS to actually run continuous integration stack. We come in the morning, we start a set of virtual servers in AWS, and in those virtual, we're going to probably run more than 20 behavior tests. We're going to build the app 20 times a day and run a behavior test every time. So think about it this way. We spin a VM in the morning, we shut it down by the end of the day, and during that life cycle, we have actually brought 20 container and destroyed it. So that's the difference.
Yeah, interesting. Yeah, good question. I think I think that you can have long-lived containers for sure, but I think it is
Continuous delivery is different because you have, if you are actually deploying to production, it's longer life cycles.
I mean, and I think it's just like physical machines to virtual machines. I mean, I think we probably took an order of magnitude decrease in lifespan. We went and probably again with containers. So definitely got some very short-lived containers for sure. I know there was another question. Yes.
So did you talk about Jenkins giving out a Docker image? In your speech when you're talking about it, did you have a use case or a situation where the Jenkins job is picking out a Docker image? Is that what you said?
Well, not spit in. It's built in a Docker image. So you try to get your developers into this mindset of each repo, and if you guys have been browsing GitHub and looking at Docker projects, you'll see that a lot of apps today have a Docker file, a Vagrant file, and some that kind of stuff. So we were trying to get developers into this mindset of each app should have a Docker file. And when we ran the build job in Jenkins, what we were doing is just we're running that Docker file, we're building that image, and we're putting it in a Docker repository. Once that is done, it triggers the whole workflow that goes through the unit test, the unit test happens a little bit early, the behavior test, and the functional testing. So we actually were trying to get them to adopt that methodology of creating a Docker file for each app. And that way, when we run the build job in Jenkins, we're actually building an image. We're shipping an image, and making full use of Docker Advantage.
So I'm still trying to picture myself, right? So you have a code, right? And you're just taking an example, you are a previously Java developer, so you may have some Java application. The code compiles to whatever jar files or WAR files, right? Then you have a Docker file. When you ship a Docker, this guy, the code is sitting outside. The Docker is just a.
I'm gonna give you an example not based on a Java code, but based on a single application app, which is a front end. So when a developer commits, does a commit, and that commit gets approved through the pull request approval process, that triggers a build in Jenkins. And what we do is actually we build a Docker image with that app installed. With the app installed.
Yeah, the app will be in the Docker image.
Layer on
Yeah.
Right. So if the app runs on an Apache server, web server, we install the Apache web server inside the container, and we deploy the app.
So
you're not shipping a Docker file.
No.
No. We're shipping actually an image.
The image, the Docker file describes how to build the image, and then the image pulls in all of the dependencies. Back when Mohamed had the monolith, that was 5 gigs, but with the microservice, that'll be much leaner.
Yes.
Then that's pulling in all these dependencies, and then what you get is effectively a statically linked executable. I mean, that's not exactly what it is. It's a container, but you can think of it as a giant statically linked thing that has all of its dependencies in it, and then that gets shipped into production.
You just seal it, and it's ready to ship to any environments that.
That's where Jenkins 2 is going. If you know where Jenkins is going, right now you have to build all your pipelines, right? You have a code, you said, but the workflow to take this particular application from one environment to the production or whatever environment, that's not part of the code, right? That's where Jenkins is going. Just like you saying you're inserting a Docker file, you're insert a Jenkins file, .jenkins. The developer says .jenkins. The Jenkins file will have all these steps to say whether you wanted to do the unit testing or to want to do the functional testing. It's all part of it, and you deliver it, and boom, it goes. The workflow is now compressed as part of your Jenkins file. Now I'm thinking myself with what you said. Now I was trying to do this in my project. Now after you said I need to build my Docker file, now am I going to deliver the Jenkins file, or am I going to give the Docker file?
Well, at the point we did it, we're trying to be true to how Docker was evangelized the first time. Docker was actually built on this philosophy of building an image on a build environment, then shipping it to different test and QA or production environments. So we're trying to be true to that philosophy, and we build the image, then we put it in a repository, then we go to different environments aka AWS in this case, and pull it and run all the tests that we want to run on that image. And that image, of course, has the newest commit and the newest version of the app.
And how do you, when you say repository, you're talking like a one Artifactory, or what is the repository?
I'm talking about a Docker repository.
A Docker repository, but I was going to actually ask about Artifactory because you can actually, I mean,
You can.
you can, and I kind of.
I think, is it Nexus or Artifactory where you can put actually Docker?
You put Docker images in Artifactory. We would do, yeah. Yeah.
Yeah, two? The
Yeah.
Pro. Okay.
Yeah. Are you guys using it? Yeah. We use Artifactory. I mean, Artifactory is like pretty good at what it does, and yeah.
But how do you version control it? Or is it like a name of a file, or is it some attribute inside it?
Well, so this part we were talking about earlier, the versioning of the image is going to be the version of the microservice. So that's how.
The name of the file that
You can tag Docker images with
Okay.
arbitrary, with the metadata.
Well, after you build your image, you can give it any name you want. But to answer your question, the version was actually based on, so if that microservice next version is going to be 1.0.1, the Docker image is going to be whatever the service, the microservice name 1.0.1.
I assume that comes from your build.
Yeah, there is some small scripting logic that we built there to actually pick up that from the manifest.
Good series of questions. Other questions? All right. Well, Mohamed, thank you very much. This is a great conversation. I
Yeah.
appreciate it. Thank you.